Hey everyone, so welcome back to Agentic AI Mastery. So this is going to be the episode 3. So in this episode, we will just deep dive into an end-to-end architect of building a truly intelligent and autonomous AI system that also we known as a Agentic AI. But before we go into really planning, memory, autonomy, let's just zoom out. Let's first look how the big picture of how an intelligent generative system is built from the scratch. So before jumping into this solution, this problem, this understanding the life cycle, I hope so you have went with the previous episode of episode 1, episode 2 of Agentic AI Mastery. So this is going to be episode 3 Agentic AI Mastery, and it will be totally on end-to-end architect. You will just truly understand how Agentic AI you can just build from the scratch, from the RAG patterns. So we will just go each and everything in much details. So let's just look at the bigger picture, starting from the scope. Before jumping with the scope, select, adapt, operate, and the use, we will just understand. Basically, we will just understand in the big picture how an intelligent system, that is generative system, is built from the scratch. So this life cycle is follow the 5 major steps. The first is a scope, then we go with the select, then we go with adapt, then we with operate, and then after finally we are using with the use case. Okay, so first let's jump into much detail about the scope. So start by answering one simple question. So what's the problem we are just going to solve? So this is like a foundation of everything, whether it's like a chatbot for the healthcare, a documentation summarization by agent, or an AI tutor. So just clearly defining the use case, giving a direction to this architecture. So example, let's say we want to just build something like an AI that helps to recruiter to just screen the resume. That's our scope, like intelligent resume filtering. Okay, then we are moving with the next step, that is a select. That is basically we are just choosing then LLM model, large language models. Next we decide should we use with existing foundation model like an OpenAI, Anthropic. We have various type of AWS Bedrock. You will find n number of models, or you should we try our own language model, our own language models. So this depend upon our budget, latency, and the control which we are just having. So example, for our resume screening AI, using an existing LLM models like a Cloudy or something like any chat GPT architecture may be faster and cheaper than any of the pre-trained model just you are just going to train from the scratch, correct? So then third is basically an adapt. So adapt is basically you are just customizing with the intelligence. It's like here we here what we are using here, where the real agentic power starts to forms. We just move from generic AI to task specific AI. Got it? Like this include like prompt engineering. Everyone know about nowadays a prompt engineering, like crafting how we just talk to any models. Something like you are giving the input to the chat GPT, whatever the prompt you are just writing, based on that it is just giving you the response. Then again we will just move deep into the RAG, that is retrieve augment generator. So retrieve augment generation basically connecting it with your our own documentation or own database where just you are storing your own data. We will just talk this thing in much detail. Also we have fine tune, we can just train it further with our own example. We can just use our existing models like GPT architecture, and then after we can just fine tune over the top. We'll just talk this thing in much detail in the next slide. And then after we have human feedback in the loop that collect the user rating to improve over the time. Sometime whenever you are just using a chat GPT, you will find something like response 1, response 2 is going to given by the GPT architecture. But that basically that it is just collecting a real time feedback from the user, and based on that it can just improve over the time. Okay, so this is what example we can just we can upload suppose 10,000 resume. Again with the same example I am going, intelligent AI screening or resume screening. We can upload 10,000 resume and the job description to create a RAG pipeline. Then AI is now understand not just language but the business context nowadays. So that is all about like adaptive. We can just go with the generative AI, and here you can just say like the RAG or agentic AI just forming up. Then we move with the operate. That operate is basically a secure and responsible AI you are going to build. We now ensure that the system behave responsibly. This means like adding a guardrails to avoid hallucination or bias towards the one specific thing. Then after we are just going to just have something evaluating our performance, safety, fairness, and the accuracy, and making it secure and complete compliant with the internal policies. Got it? So like we can just again give with example. Suppose our resume AI should avoid any bias towards the a specific gender. It's not be biased towards the male or towards the female or any university that has really the big names, something like IITs and NIT. It's not biased based on these things. It will be totally a fearless. Okay, so this is what about the operate which you need to just prepare before just building any agentic AI solution. Then we have a use. If finally we will just talk into live this into basically connecting it into real user and the system, whether you want to connect with any application, any use case where you are using this all thing, where you want to utilize this generative AI powerful. Then after monitoring this performance, how well these are the performing, then we are just ensuring the regularities or compliances from this specific use case, and that helps using this LLM ops. You'll just find the ML ops, LLM ops to just continuously improving something like a CI/CD and CD pipeline which you are just building, and it just improve over the time. Correct. So example again we can just give, we embed our resume AI into a recruiter portal, and then after we just keep the feedback tracking to fine tune the result over the time, whether we can just connect with them to just think like how our model is really performing well. We can just take a feedback from that. So this is all about end-to-end life cycle of generative AI system. So we can just wrap up this slide. So this is all on the micro view, we can just say. It's like a building a car. I will take another example. I hope so you will just understand. So it's like a building a car. First you decide what type you want. So basically this is building a car is like a scope. Then after you are just going with the select, like what type of what type of you want, like what type of engine, customized engine, installing a brakes, safety system, and finally drive into onto the roads. These are the things which it comes with the scope, select, adapt, operate, and the use. Okay, so in the next slide again we'll just talk more about the agentic AI, and this is going to be one of the most important slide. Now that we understand about the overall life cycle of generative AI, now what we will just focus, let's start looking how this generative AI system are actually built, and this inside any organization. Whenever you are just talking about, if you're working in real time any organization, or you are just going to do some startup, so there you will just find like you are using an LLMs models every time, somewhere from the AWS Bedrock, somewhere from the GCP, somewhere from Azure. So even your own model can be used. So basically this is the most common, and you will just find something really common this thing nowadays. Everyone is building an AI agentic AI system. So in the simple terms, we usually build an gen AI system in two ways. The one is basically black box LLM APIs. What does it means? So we don't basically we don't host any model ourselves. Basically what we do, we simply send our prompt to the LLMs. This is the large language model. You are just user, you are sending some of the prompt those LLMs, and based on that you via any APIs or the UI application, and you are getting some of the response. So that is what it is. You are not even what you are not even controlling the models. You don't know what's happening inside the LLM. You simply what your user will just give the prompt via either APIs or the UI. You can just take a real example of ChatGPT, something like this, where you just providing some of the prompt, and now you don't know what's exactly is happening inside this ChatGPT, inside the model. It's totally a black box from us. You are just simply providing the prompt. You are just getting a result based on whatever the LLM provider or the model which you are using. Okay, it's called a black box because we don't know what's inside. We don't control the model, the training data, or any even the architect. We only get the output by talking into this. Whatever the prompt you are providing, you will get a response. So example again I will give you. Imagine you want to just build an AI email system that basically summarize inside your application. You want to put one function inside any of the application that summarize your email. You could just call an OpenAI APIs directly, send the full email as a prompt, and ask for the summary. It's basically easy, fast, but again limited control. You are not controlling the system. You are accessing via the APIs. So this approach is a great for the rapid prototyping, but come with the challenging, like no access to the internal model reasoning, hard to enforce any privacy or any compliances, or limited customization. These are the really some of the challenging you will just face while using this black box LMs APIs. Second, which we are just talking about, like enterprise apps in the LLMs app store, we can just say this is really a newer and emerging model where companies nowadays they use an LLM power apps built on the top of any public or a private data. It can be a public data, it can be private data. They can just train their own LLMs models. Okay, now instead of just using LLM directly, you can even use a pre-built app that wrap up around the models, and it just tailor a specific use case. Let's take again one example. I hope so you understand. Let's say a logistic company, something like delivery delay or risk prediction, something they are just building an application which is trained on logistic data, and that wrap ups around the LLMs model. Correct. Now you can access this via an app interface or any plugin, not by calling this LLM directly. So what you are just using, you are using LLM, they are using organization, they are using this one. But the main thing is that they are just using their own data as well as for the any something like just pretending their own LLMs model. By using on top of that, they are using their own data, so that they can just give you a specific solution with their specific data, with their specific challenges which they are just facing. They can't use for the public, they are used for their own organization. Correct. So this is what enterprise app in this LLM apps store which you are just finding nowadays. So in this, basically in the second approach, I can just say key difference, something like you can still rely on the external LLMs model, because whenever you are just training any models, large language model, that is already have been trained on billions of the millions of the data. They have billions of the parameters. Now you are just freezing that parameter, and on top of that you are just providing your own data, and then after you are just training that models. Again, you are dependent on a specific LLMs model as well, but you are using someone else model again, because whatever the model you are using, again this is for someone else. You are it's not even yours. So but basically what you are just doing, you are just using someone owns model, but someone owns data. These are basically the caution we can just say from backend. So you, if you want to just develop from the scratch, where you are not using any data, open source data, you are providing your own data set, and this all thing that's happened, that depend totally on the what challenging, what the problem you are just going to solve. So this means like it can be faster to adopt, but you must be verify the models data ownership, training ethics, something like this. There are many of the challenging is there. Okay, so we can just wrap up the difference between them, like black box LLMs API and enterprise apps in the LLMs app store. It's like it is like fast and flexible, so you can just take an APIs, just whatever you are just sending the prompt, you will just get a response. But it is basically is a domain specific secure, something like if you are just solving a problem that's related to the, so just now I've given the example, like you are going to track how fast your any of the obstacle is going to take place, or something like email marketing, something like anything that related to their own organization they are using. But they have limited control. They don't have anything control in this black box app. This is the second difference. But again with the this, that they are easily compliances. Even you have somewhere like a control, because you are using your own data, but you are just wrapping on that LLM model, and top of that you are providing your own data. Just use plus an API, that's it. But here you are just hosting, you are just training, you are just top of that, you are just wrapping on that LLMs, then you are just providing your own APIs. So this is the one you need to just form. Like you can just build your own LLMs models, but you are just using that LLMs model, you are using their already open source model, plus you are just training on top of that with your own data. Then after you are getting some good LLMs model based on your use case, and then you are just wrapping on the you are just providing this thing via any APIs. Again you are using as a third party. Basically you are using a third party model, basically means that you are using an LLMs model in the backend, but on top of that you are just providing your own data, and then making that LLMs as your own use case. So that is like plus point, even like you are just solving your problem for your own organization. Okay, so yeah, this was all about the architect of like how we are just get the difference between black box LLMs APIs and enterprise app in LLMs based. Okay, we'll just move with the third slide. So now let's dive into an actual architect for a building a fine-tuned intelligence system that learns from your data and acts like an expert agent in your domain. Okay, so by looking this diagram, I hope so it looks little bit complicated, but I will make sure this I'll make sure that I will just make you understand each and everything. So let's first start with the public plus enterprise data. What does it means, this data? So public data is basically an open data like a Wikipedia. You can find or anything code related problem like Stack Overflow, legal documentation, and number of things is available in the Google. They all are a public data. You can just use that public data for your own training of the models. But again, there is something like enterprise data. So enterprise data is basically an internal documentation, knowledge base, customer chat log. These are the something that already their own enterprise data, your own organization data, they are just holding for training the models. Again, so you can just combine this both, and then after you can use for the LLM training. So it is like a raw fuel that power our intelligence. If we are just building an insurance assistance, we may combine like public insurance FAQ, and then after internal claim documentation and historical chat conversation with this agent. So these are the things which you combine and then get a better results, because we whatever the data with organization will have, that will be not enough for LLM's model to train. You need something like public data as well, as to see how this public data is behaving based on this LLMs, and you are just wrapping on top of that. The second is like data processing pipeline. I know this raw data is really messy. You whatever you're just providing a data from a different type of Googles, you can't directly fit to the LLMs, because nowadays whenever your data is really clean, your model will give you the better accuracy. It totally depends upon how you are teaching your LLMs model based on the data. So that you are just cleaning it, you are just normalizing it, removing something like stop word, chunk, HTML text, broken sentence. So these all thing data processing, I hope you know about from machine learning, from the deep learning, various process which we are just doing this data processing. You can think of this like washing and chopping vegetable before cooking. So these are the things that I'm just making some of the example. If someone is really in the first time to understand this architecture, it will be really hard for them. Then we are moving with the knowledge graph plus embedding. What does it means? Now we enrich this data. We just build a knowledge graph that show how idea are connected, like policies, coverage, or any occlusion. Okay, so that basically we just generating a embedding, so that which are vectorizing machine readable forms then of the knowledge base. Basically we are not putting any direct sentence directly to the LLM's model. They don't understand in a string and all. You are just converting into a numeric form. Again, that numeric is going to be really huge. That's why you're just converting into vector form. You will just see the word to vec, many of the things, that is concept of natural language processing. That is what you are just storing in the knowledge base in the vector form. Okay, so this make really searchable and learnable for the models. They know that okay, this is the memory. It's like a brain memory you are just storing in this knowledge base. Then we have something like open source pre-trained LLM models. At this point, we take a open source model like any Llama model, a Falcon model, any open source models. So these are like general purpose models, like a new employee who speak like fluent English but does not know how your business is yet to start. They whatever the new hire which is coming to any of the organization, so you are just giving some of the KT, like how your organization is just building your models and XYZ based on whatever they have just built from the past experience. So you are just giving they are just coming with their own experience, plus you are providing this KT. It's like you're providing a prompt. It's like enterprise data you're providing, and they already have the public data information. Correct? So what we do, like we just fine tune them directly. So now based on that, what we just do supervised fine tune with a few short learning. It's like something like this is like training room you can just take about. So here we saw that models, like here how we just claim documentation, like this is what then AI should say something like this. Here like something like how model will say, like here customer question, this is not a right response. Here the claim documentation, this is what then AI should say, something like this. It will just give you the response. So few short learning means that we don't need a huge data, just well chosen example. That's it. It will just learn based on that prompt. So we also embed that one is a ethical AI safeguard, like rules to ensure like fairness, safety, compliances. These are the again the next step process. But again, whenever you are just building any application on the agentic AI system, generative AI system, you are just keeping in mind that these are the things which you need to have take care. Then you will just somewhere you will find that SLM API. What does it mean? Basically small language model, that is SLM. Basically instead of retraining a giant LM's model, what we do, we often just distill the logic into a domain specific smaller model that optimize for the speed, cost and context. You don't need a large GPT billions of the architects for building a something like a resume summary. You don't need that billions of parameter in that. You just take a small few short learning you're providing, and based on that your model is just done, it built. That is what an agent brain it is. Then finally what you are just doing, you are just deploying into a mobile. Whenever you are just deploy into a deployment process will be there, like any mobile or any web API through, you are just giving the access. So once you train, this intelligent model is plugging into a user interface like any chat app, dashboard or API. You just send somewhere like prompts, some like summarize this documentation. Then after the model responds and the learn over the time. This is again the learn over the time basically means that you are using a concept of reinforcement learning, human based feedback loop. So this is basically the one of the most important thing. It takes a feedback from the user. Okay, so I will go again a little bit detail in the further slide. It's like you will just find RLHF, model monitoring, model caching and model versioning. So versioning in the model is basically so we can roll back if we need different type of version which we have. Cache is basically made response to reduce any loss. They already have the information what you are just doing. Monitor is it's like a quality, what's the something like you are just evaluating your the models. Then that is basically you become with the model RLHF, basically reinforcement learning from human feedback, so that we can improve it from the user score. User can give us the feedback, okay, this is going to be not a bad response and something like this, so they can just learn this thing in the real time based on the tokens. You need to just know about the reinforcement learning concept, but again we will have a separate video on these things. So this is now overview which I am just giving on. So think of this like a DevOps but for the intelligence which we are just building. Okay, so now we can just wrap up this entire diagram showing that the core engine of the advanced agenting system, it learn from your data, whatever the data you're providing, think in your context, then follow ethical rules, whatever the rules we is providing, and improve continuously based on this feedback. So in the next slide again we'll just see about again the RAG in the GenAI architecture. Again this is going to be all right. So now let's talk about, again we'll just go with the RAG that we call is Retrieval-Augmented Generation. If you heard like first like AI that no use documentation or context aware chatbot chance as they are the power by the RAG, simply by the RAG. Let me explain what this architecture does and more importantly why it matters. So why RAG? Simply you will have a question like why RAG we are using. First let's say you want to just build an AI assistant, suppose, and that know all the company policies or training and manuals, anything that's like that. You could fine tune using an LLM with your content, but that's expensive and the time consuming. That is the key point that we have. That is totally expensive and time consuming. What you can just do, you could not fine tune an LLM with your own content, but that's a really it will be time consuming, it will be expensive, you will not have enough data set as well as. So instead of what we can just use, we can use a RAG. We let that LLM stay general and simple, attach a brain full of your data, that's it. You will have an LM models that already have been trained on billions of data set. Now you are just attaching your own documentation, you are just fooling the brain with your own documentation which it retrieve on the fly, correct? This is like a Google plus chat GPT, but instead of your company are far smarter for now. Okay, the next step you need to understand about the three things like retrieval, augment and generate. A user asks a question like something like what are our refund policy for our international order, something like this. We convert that query into mathematic fingerprint which we call as a embedding. That is what we have discussed in the previous slide, what we call as knowledge graph. Inside this we are just storing embedding vectors we have. So once we have, and just compare it all the stored chunks into a vector database. Again this whole thing again I will go in the much detail, but first you just understand what is happening in this three step. Okay, so this is basically you let's understand with the example. Whenever we are just providing with what's our refund policy, we send here is the policies action, now answer the question using this gives the model grounded specific content. Like real world example, I can think of a lawyer answering a question using a section pulled directly from any contract, anything. So whatever the section you are just asking to a lawyer, it will just give you the response based on this section, similar kind of things which we are just building in the RAG pattern, correct? Then that is what we call as augment. And then we will have retrieve, we will have augment, we will have generate. And now I'm just going to in much detail in this, and I hope so this time you will just understand this thing. So basically the first thing is basically you can see retrieve, this is totally augment, and then after totally it has generate. So if you are going to go with the definition, retrieve basically transfer user query to embed, so that it just compares similarity score with our content. This again I will give you the example. Augment is basically we just search the result which you already is stored in the vectors database, and then after generate, based on that whatever the top most like similarity chunk has been just it has been chunked, based on that it will just give you the response. So this is the things which we'll just go in detail. Step one is like retrieval. Retrieve is basically a user asks a question, something like this. Again I will go through what our refund policy for our international order. Okay, so we just convert that query into mathematics, something like this. You're converting into embedding and comparing and storing into a vector store. Okay, and that compare it is stored chunk which is already stored in the vector store. So I will give you one example. This documentation, you suppose you have 1,000 documentation, you already have done chunking, you have already stored in the knowledge base database, that is in the form of vector store. Your database that is a vector store is already storing all the data relevant to your specific use cases. Okay, and then after a user simply querying a question, something like it will just query a question, based on that it will just retrieve a data from where it will just convert whatever your user query into embed vector, and based on that it will just chunk that vector if we have really large files, and based on that it will just search from that vector store. So they will just search from that vector store, whichever the whatever you are just searching, based on that whichever having the top 5 top 3 most relevant chunks, most relevant answer of that, and based on that what we call as augment. So this augment is basically we are just retrieving the most relevant chunks we just attach from the user prompt. Okay, so instead of just sending what's our refund policy, we send something like here is the policy section, now answer the question using this, something like whatever the documentation which you are just attaching. So this give the model grounded specific and context. Okay, so like and then after based on that you are just going to generate this one. Generate is basically it's like a model that has already user question plus the relevant content. So whatever the query it is they having, it will just take plus that is basically a prompt plus the relevant content which is just extracting from this vector store. A vector store is giving you the most relevant content which is already they have a stored from the thousand PDF files or any files they have. From that they will just take the most relevant content whatever the user is query, and then after it will just send to this, it will just send a something like it will just update that prompt query plus relevant chunks, and then after it will just generate the response based on your LLM's models. So this is what it's happening. Then like now with this model has user question plus the relevant content, just that for that reason it can generate a response. You can use any LLM models, it is available in the market, OpenAI or Anthropic on any of the LLM's models, but this response is no longer generic, it just inform PCS and backend by the data. That's it, whatever the data you have is just giving you the response. Like okay, so this is what we can just even the breakdown. A query is just enter into a query is sent into a retrievals, and then after we retrieve a relevant data, then after this data is already stored in this vector form, that chunk inside a vector store, we update that prompt template. This is the prompt template that adding a relevant info, that is a query plus the relevant chunk based on this query. That is what we call as in RAG, and this LLM read, and you are sending this all information to LLM, and this is like a brain, and based on that it will just generate your response. This is what about the RAG. I hope so you understand this whole thing. It was really straightforward. So again, why RAG fit agentic AI as well? So basically, you can have agentic system needs like long-term memory, real-time reasoning, dynamic knowledge of lookup. These all things we need for the agentic AI. So RAG gives us that all without needing to retrain model continuously. So it turns static LLM into adaptive enterprise-ready agent. Correct? So we can just wrap up this like RAG is like a retrieval, that is basically a smarter engine but generating, that is basically a LLM magic. It just make you AI contextual, grounded and enterprise really safe. So again, we'll just move with the next slide, and I hope so you will just understand each and everything in much detail. And this is going to be our like, okay, we'll just go really what, think of this like a building with a Lego block, something like this. So each block is one agent, and then after we'll have different agent, agent 1, agent 2, agent 3. We'll have different orchestration layer, we'll have enterprise layer. What does it means in this? So this is something like really powerful how agentic AI is involving beyond our single agent. Here we are just seeing the multi agent concept. Okay, so we are just talking about a full platform designing with a multi-agent system that works together inside an enterprise, almost like a digital workflow. Correct, you can just think about this one. And I have collected this, this already has been done research by D Vishwas. He's really good researcher. I just went with this paper, I collect the information from his. So this is really the some type of this which we can use this to building an agentic AI platform using various type of principle and the patterns, so that we can use a multi-agent concept in this. So what is this really about? Let's talk about things. So think of this like a building with a Lego blocks, something like this. So each block is going to be one agent. You will have one agent, that platform, the table that help them to stick, talk, building, or something like larger, which I'm just explaining in the layman terms. So instead of training one mega agent, we can compose many smaller agents. Correct? So each skill is something specific. So you can't keep one agent to do everything. Something you will just something like this. One agent you are just building for a PDF summaries. You one second agent you are just building for something like healthcare is agent. Something agent 3 you are just building for something like transport or something like this queries, real time booking system. So every agent you are giving a specific task. You are not relying on the one agent to do multiple tasks. Okay, but you are building an agentic AI system where you are just using all multi-agent concept. So now let's break down into a marketplace. First of all, I will just talk about this thing. What are the agent marketplace? They're just like an app store. Just imagine like a catalog of a pre-built agent, where one is for the customer support, one might be for invoice in extraction, one might be for the fraud detection. So these might be the agent marketplace. So these are the reusable and composable. Okay, example, need a build and insurance assistance, or grab a claim agent plus the customer query agent, something like this. Then we have orchestration layer. So this is the brain that say like who talks to whom. Correct, like when should they just turns, what's the overall workflow they have, something like this. Here we have two parts basically. You can just see orchestration engine and orchestration schema. Orchestration engine basically decide which agent to activate based on the contents. Okay, so you will have a orchestration engine will basic. This is going to be really in the future use case, which I will say much of them even don't understand how we can build a multi-agent system where we can't use any orchestration and all. So these are the things you need to just understand. Agent marketplace, you know that you are just having n number of agent, and each agent have different use case. Then you will have an orchestration layer. That orchestration layer is like you there we have two parts. One we call it orchestration engine, another we call it orchestration schema. Orchestration engine basically just decide which agent to activate based on the contents. Okay, or whatever the problem you are just giving. And we have orchestration schema. It just define the flow, like think it like a workflow, a blueprint which you are just defining which schema it need to invoke. So example, if an HR bot cannot handle a question, the orchestration layer routes it into policy reading agent. That's it. So this is basically a smarter, it can just route to that specific agent use case based on this whatever the orchestration engine is trailing the description of that goal, and orchestration schema is going to just take overflow. It's like it just connecting to the different agent. Okay, then we are just going with the integration layer. So integration layer is basically is like this connect the agent works with the real enterprise system like CRM, database, HR tools, or different type of things which we have, or any APIs. So your agent does not just think, they actually do things like updating a record, fetching a documentation. Like some example I'm just giving you, agent read leaves balance from the HR system and answer in the real time, something which is really the basic example I'm giving. Okay, so and then we have a shared memory layer. This is going to be really the most important thing. Agent does not work in isolation, they share memory, so they know that what happening earlier, what happened before, and what another agent did. So they have all the information about the different agent, their collaboration, their thinking power, and everything they have. Okay, think of it like a Google Docs where all the agent can write and read. Correct? Without this, agent will forget things or just duplicate effort, whatever they are just doing, whatever they have done from the past. Okay, then we will have a governance layer. What does it means with this, like privacy, secure, and all? Like we have privacy, we have security guardrails, we have data leakage, and this all the thing are there, which basically means that you don't want something to be it should be really more on the security purpose, because you are building for your own organization, your own use case, whether you are doing a startup and all. So think of it's like a legal, totally legal things which you are just building, plus ethical traffic cop. Okay, so how user fit into this, how user just fit into this? At the top of you can just see, you will see a user loop. Okay, so we just add a response personalizing while ensuring that we have security, we have we are just following with the guardrails, we have something privacy compliances. Okay, so even the user talk 3 to 5 agent, they get a smooth, a secure, and unified experience. Correct? So we can go with the agent 1, agent 2, agent 3, and beyond that. This platform lets enterprise compose that intelligence, like agent 1 reads the data, agent 2 analyze the trend, agent 3 send alert or automate the action. So this agent could use RAG, fine tune, or even external tools that can orchestrate, handle what does what. Correct? This is my final thought I can just give. This is not just a theoretical, but it is like a future of the enterprise. So even much of the many of the organization, they did not have built this type of workflow even, but this this might be a future, you can just say. Like in the future, we have composable, we have orchestrator, we have governance, and then after we are just building a secure. So we are moving from a single brain AI to a multi agent ecosystem. So you will have multiple brain there, and each brain have different tasks. Okay, so it can be scalable, reusable, and far more powerful. So that's all from my side for this. I hope so you understand in this. So